Hey y'all, so I'm just going to help you with exponent properties. We did them right before break, way back in the day. So if you forgot them, they're all up there at the top. You do also have that exponential foldable that we made, and you'll have these on your star chart. So you don't have to have these memorized. I'm just going to have them there to kind of help us. So number one, we have 2a to the 8th times 2a to the 6th. So remember with exponent properties, if we have any coefficients by themselves, we just multiply them by themselves. So 2 times 2 would be 4. And then our a's, because it is multiplication, we add the exponent. So a to the 8th times a to the 6th, we do 8 plus 6, which would give us 14. And that would be our final answer in this case. So all we're doing is using our exponent properties to simplify these statements. Okay, let's look at number 2. So 3d squared to the 3rd. Okay, so first thing I want to do, anytime I have powers to a power, so I have stuff inside parentheses all being taken to a power, anything that doesn't have an exponent, I want to go ahead and give an exponent of 1. Okay, because that's going to help me do this multiplication. So there's two things I do here. First off, I distribute the power to both, and then because it is a power to a power, I multiply. So I do 3 times 1 and 3 times 2. So this becomes 3 times 1 is to the 3rd, and d is 2 times 3, which is to the 6th. And then I can leave it like this, but if I need to, I can multiply this out. 3 to the 3rd is equal to 27. So 27d to the 6th. All right, let's look at another one. Number 3. We have 10ef cubed, all raised to the 5th. So anything that doesn't have an exponent, I'm going to go ahead and give an exponent of 1. Then I take that 5, distribute it to everything on the inside. So 10 to the 1st times 5 becomes 10 to the 5th. E to the 1st times 5, that becomes e to the 5th. F to the 3rd times 5 becomes f to the 15. And then I can leave it like that, or of course this is 10,000. Sorry, 100,000. E to the 5th, f to the 15th. And that is it. Nice and simple and straightforward. So I'm just using these exponent properties that are up here at the top. If you've misplaced yours, feel free to write these down as we're working through these notes so you can follow along with me. All right, so number 4, now we're dealing with division. So we have f to the 8th over f cubed. So our division rule, a to the m over a to the n, we subtract the powers. So anytime it's division, we subtract them. So 8 minus 3 would be equal to 5. So f to the 5th would be our final answer in this case. Okay, same idea on number 5. But now we have multiples. We have x to the 7th, y to the 3rd, and we have this 35 over 7. So just like up in number 2, where when we had numbers by themselves, we just multiplied them because everything is being multiplied. In number 5, when we have numbers by themselves, we're just going to be dividing them because everything is being divided. So 35 divided by 7 would just be 5. Okay. X to the 7 over x to the 7. 7 minus 7 is 0, so that would become x to the 0. Y to the 3rd over y to the 3rd. 3 minus 3 is 0, so that becomes y to the 0. And then going over to my properties, anything to the 0 power is equal to 1. So this becomes 5 times 1 times 1, because this is still multiplication, of course, here in the middle, which would just be equal to 5 as a final answer. Okay, last but not least, and this one's going to combine all of our skills. Okay, so we have numbers on the inside of parentheses being raised to powers. So first and foremost, I have to go in here and add my 1s to my exponents. Then I'm going to distribute my powers onto the inside, and of course when I distribute I multiply. So this becomes 4 to the 1st times 4 is 4 to the 4th. J to the 2nd times 4 becomes j to the 8th. K to the 3rd times 4 becomes k to the 12th over. Same thing, but now I take the 3 and distribute it inside. So 2 to the first times 3 becomes 2 to the third. J to the third times 3 becomes j to the ninth. K squared times 3 becomes k to the sixth. And then from here, I want to divide everything, but before I can do that, I have 4 to the fourth and 2 to the third. I can't divide those right now, so let's go ahead and actually get those. So 4 to the fourth is 256. And you can, of course, type that in the calculator if you need to. 2 to the third is 8, and then j to the eighth, k to the 12th, j to the ninth, k to the sixth. Okay, so 256 divided by 8 is 32, and of course, I did that because it's just numbers by themselves, so I just divide them like I would normally in a fraction. J to the eighth over j to the ninth. 8 minus 9 is j to the negative 1. K to the 12th, k to the sixth. 12 minus 6 is k to the sixth. And then last thing, anytime in a exponent property that I have a negative exponent, negative means to change its place in the fraction. So if it's in the top of the fraction, I move it to the bottom. If it's in the bottom of the fraction, I move it up to the top. So in this case, in number 6, I have j to the negative first, and it is in the top. So this would become 32k to the sixth over j to the first, or just j. Okay, so notice how that negative exponent means I needed to move it down to the bottom as my very last step. All right, y'all, that is exponent properties in a nutshell. Go ahead and work on the review activity.